Welcome back. My name is Jack Burgess. As promised, this is the second video on styrene. And on this one, I'm going to concentrate on some different ways of doing the same thing. The first one I want to talk about is layout. How do you draw on the styrene what you want to cut? What's the best way to do that? And there's different options and so forth. So I'm going to be talking about this plan. And this was a little handcar shed in the Merced yards of the Yosemite Valley Railroad. I had the dimensions on it, and I had one picture that showed it in the very, very back of the photo. And so from that, I was able to draw it up. I built it. It's on the layout. I built it out of styrene. And so I want to use that as a simple way to talk about some of these other things. So one way you could do it is to simply mark the styrene. One obvious solution is to measure what's on the plan. In this particular case, the width of the building is 12 feet, and use your scale ruler to mark off 12 feet. I mentioned this before, but what you want to use is a drafting pencil. These are available from Amazon. And mark it, and then take your square, get it lined up, and do the scribe and cut. Now, that works, but now you have to have a second piece, which is supposed to be exactly the same width. And if they're not, then your building is not going to be square. So one way to do that, which would be kind of wasteful, but you could make a cut the long way, and now the width, then you can make two of them, two ends out of that one piece. You're wasting a lot of material. Another way you could do it is use dividers. These are drafting dividers. I've had this one since I was in high school. I use it quite a bit, and they're not that expensive. I would guess maybe 10 bucks. You want a nice one. You don't want one that's all sloppy. And what you can do is you can actually take the measurement off of your ruler, if this will go wide enough. So there's 12 feet. And so we can then take this and make a mark. Now, this has an extra advantage. And what you might want to do, since I've already lost it, let's do another one. And you see I'm turning this to kind of make a little hole. There it is. So then you take your square and you get as close as you can, and lightly, I'm not making a line, I'm just lightly dragging across. And if I'm lined up, you will feel when you get in that little circle. So I'm off a little, try it again, and I think I just hit it. So then you can make your mark. Then what you could do is you cut and slice that one out, and then you do this again, and now these two pieces are going to be exactly the same width. So you can, this one, I also have another one that's even bigger that would let me do the other dimension. So that's one way to, when you're doing layout, that you can make sure that it's as accurate as possible. And when I say accurate, what I'm really saying is you want the building to be square. So if it's 12 feet or it's 11 feet 9 inches wide, that is not as important as having both ends and both sides exactly the same width. And I know that many times I will draw up a building based on an assumption of the width. So I might say, okay, I think the building is 50 feet wide because of whatever. Maybe I measured it on Google Earth, the building is still there. Then once I make that decision, I want it to be exactly 50 feet wide as the model. Now, you don't need to do that, but I'm a perfectionist when it comes to that. So that's just my standard. And I think also, if you always try to be as accurate as you can, your modeling will improve when it really becomes critical that something be accurately done. So maybe the length of a boxcar, if it's off a little, no big deal. But when it comes to drilling holes for grab irons, now you have to be accurate. Because if you drill the hole and it's a little short or it's too long, it's not going to work. You're going to have to fill it. So I think that's probably the lesson, is be as accurate as you can all the time. Okay, a second option, which is maybe the accuracy may be a little bit better, because drawing a pencil line on styrene is not as good as drawing a pencil line on paper. They're designed to work together. So you could take a piece of paper and lay out the same thing, walk your little thing across, dink dink, so forth, and then draw it in pencil and use that as your template. Now, one thing I want to point out is there is a reason I spaced these as I did. So I've got some pieces of paper here. Here's the two sides of the building. Here's the two ends. You could do these any way you want. You could draw them up like that, or this, or whatever. But if you put these two pieces together, when you set the height of both pieces is going to be exactly the same. The width you can't do anything about. Likewise, the height of this has to be the same as the height of the end. So if you do it like this, then you're minimizing errors. You can use your dividers. Now this is way bigger than HO scale, obviously, but you can set the dividers to do these widths together, these two together. Then what you could do is take your paper print, cut it not on the lines, but outside the lines, put upside down on a newspaper and spray it with repositionable spray adhesive called Spray Mount. These are easy to get. The craft stores and so forth carry this. You spray it on and take your paper, turn it over, stick it on the styrene, and now you've got it. You can cut right on the lines. What you would have to do is cut first on this line with your ruler. That becomes the square, and then you can use your square to cut all the rest of the stuff. So that works pretty good, but it's kind of a hassle using the spray adhesive. So what you can also do is use sticky back. This is sticky back, and you see I print on white side. That is the side you want to draw on. So you can draw your pattern on this, peel off the back and stick it on. You don't need to use a spray adhesive. So that works out pretty well. So this one is the same sides and the roof. Now, if you look at the plan, you'll notice that this door is not where it is supposed to be. It's supposed to be over here. Remember, this is going to go on the back because it will leave some sticky stuff. Or if you're using scribe styrene, you don't want to put this on the scribe side, so you want to put it on the inside. So you have to reverse anything that's not symmetrical. If there's a window on the left, draw it on the right. So that works pretty good. Another tip when scribing lines, and I do this quite often, is especially if you're cutting out windows, you scribe a line. You're not going to break it there, but you're going to cut a window. And then you're looking and you can't find your scribe line. Here's one good reason not to dust your workshop. You reach over, get some dust on your hand. The line is easy to follow that way. Okay, now I want to talk about cutting out holes for windows. Windows can be a challenge. You can't put them on there and trace them out because unless you're building a masonry building, there's always trim around the windows. So what I do is you need to transfer the width of the window onto the styrene. So on the back side, so this is the front side that'll face out. On the back side, use calipers to measure the width. And this is a pretty cheap one. It doesn't work. The battery, I had bought two of these from a store that sells cheap tools. And one of them you couldn't turn off until the battery wore out. The other one, it would eat the batteries within a week. So I don't know why I still have them around. Just to demonstrate, I think. What I finally did is I bought a professional one. This is what machinists use. This is kind of the standard of machinists for this particular brand. it actually goes to 3 decimal places instead of 2. Well, no, this is going to 0. But it's very smooth, and I can leave it on for a week. I try to turn it off each time I finish using it, but when I forget, I might come in 2 days later and go, oh, forgot to turn off. It's the same battery I've had in here for 3 or 4 years. So it's very good about batteries. It holds the 0. It measures in both inches and millimeters. And the smoothness is just really nice. But for this one, we don't care what it says. All we care about is these little points. So we measure the width, lock it, and then one hole and the other hole, and circle them. Now, and of course we would have needed to measure from the side or end, you know, we can't just arbitrarily do it in the middle. And then do the same thing for the height. So now we have the height of the window. We come in here and make 2 holes. And you notice I was really pressing those in. Okay, then we're going to cut out, we're going to scribe around the hole. We're not going to try to cut it out. The old way of doing this was you take your X-Acto knife and you cut as deep as you can on all the sides, and you keep going, and then you cut acrosswise and try to break it out. And it would take you literally, for this window, probably 5 minutes to get through that window. So we can catch these holes, and we don't want to go beyond them. And you know, if this is the outside, you don't want it to go too far because it's going to show. If this is the inside, then you can, if you go a little bit too far, it's no big deal. So, and you can actually hear maybe dropping into those holes. Okay, now I'm going to take some dust and make those visible again. So now, what we do is take the X-Acto knife and somewhere in the center, start turning it. And you could drill this out, and I even have a drill press, but I find that this is just as fast as I need to be. Now we start carving out, and we're not going to carve up to the line. We're just trying to make a hole. It needs to be a little bigger. Okay, so this is good enough. So what we could do, this is called a nibbler, and they are really for making holes in metal, sheet metal. Especially back when people were doing their own electronics about 30, 40 years ago. They're still available. You can get this on Amazon. I used to buy it from Radio Shack, but of course they're gone. But Amazon carries them. So you come in from the bottom and then just start nibbling up to the lines. And the head is square, so you can turn it around. And what I like to do is don't get too close until you can reach all the way to the edge, if that makes any sense. So if I take a bite right here and get too close to the line but not all the way to the line, the next bite is going to be really, really small and it's not going to work very well. So pull back a little bit until you can make a cut right up to the line, like right there and right there. So just keep working yourself around. This will go right into the corner. Once you get into the corner, you can go straight along the line. Turn it again. So I'm pretty close to the lines, and at this point it's just trial and error. So keep working until you've got the size hole you want, and then you're ready to glue it in place. Okay, another trick, sometimes you want to cut a piece of V-groove siding right down a groove. And it's very easy to get started and then swerve off because the grooves are not set up for that. So here's the trick to do. First you take your pencil, the drafting pencil, and mark the groove all the way down. Then you use your X-Acto knife, but you hold it nearly level. And just go down real slow, real close to the styrene. And this is one reason you mark it. You want to make sure you go down the same groove next time. That time you can go a little more pressure, and then it will snap off. So I've showed you some simple ways to do layout, cut window openings, and so forth. What I'm doing now, though, is a little more high-tech, but easier, more accurate. I'm drawing the parts up in CAD rather than using a pencil, and that I take that artwork, import it into a 2D cutter, and it cuts out the parts, including the window openings and whatever. So let me show you the CAD, where I'm talking about that, and then I'll show you the demo on cutting out styrene with a cutter. So this is the CAD program that I'm using. I've been using this for about 30 years. I'm running it on an old 486 computer, and which tells you how old the program is. And when I upgraded to a Pentium computer, it wouldn't run. I talked to the manufacturer or the designer, whatever, distributor of the program, and he just laughed at me. He said, "You can't run that program on a faster computer." So I actually have 3 towers. One tower is nothing but CAD, but it still works, gets the job done. There are CAD programs all over. There's free ones. This program is called Auto Sketch. It's no longer available, but I use it because it's fast and I've used it for so long. So this is the drawing that you saw earlier. And what I want to do is give you a real quick shot of how I go from here to the next step. So what I've done is I've copied the in view onto another page, taken the roof off, I zoom in, get rid of all these lines, and if I cut this off and that off, okay, now I have the template for the end. Now I take that and do just what I was talking about before, is there's the 2 ends, there's the 2 sides, the opening for the door, and there's the roof. And you'll notice that these lines extend beyond the ends. That's because it lets me snap the stuff out of the final piece of styrene easier. So for that, then I take this drawing, save it as a certain extension, and that can be downloaded into my Cricut cutter. Okay, so I've uploaded that file to the program that runs this Cricut cutter, and put a piece of 20,000 styrene on the sticky material. That'll hold it as it goes through the machine. It's telling me that it's ready to go. And you can control through the software the number of times it cuts each line and how much pressure it puts on it. And through kind of a trial and error and what other people suggested, I'm using 6 cuts per line. So you see that what it's doing is it's cutting the same line 6 times in a row, and then it goes to the next line. So it is now 6 minutes later. This is all finished. And if you can see that, you can see where it's all cut out. You can see where it's cut beyond the lines. and all we're going to do is peel this off and pop these suckers out. So we do that by bending the sticky mat. I don't know what they really are called. So now we have this is done, and still need to take an X-Acto knife to some of the cuts, but basically everything is all cut out and accurately. Everything is, these two are exactly the same width, these are the same width, and so forth. So now I have cut these out. All I needed to do is take my X-Acto knife and touch up the corners, so forth, go down the lines. So that took maybe 30 seconds. And so these are all cut out. They're accurate. We know that the ends are going to be exactly the same width, so forth. So this is, the tool is maybe about 250 bucks, I think, the cutter. As you probably know if you've watched some of the other videos, I don't mind spending money on tools. I don't spend money on ready-to-run cars or ready-to-run diesels, so forth. So I get my money's worth out of this because it's faster, it's more accurate, and on very complex projects it makes it a lot easier. So that does it. I hope you learned some tricks and some techniques in using styrene. It's a great material to use. It's fast, bonds easy, and it's very clean. So with that, hopefully we'll see you next time.